Okay, today we're going to learn about common and natural logarithms. All right. So what is common log? Common log is a log to the base 10. All right. So natural logs will be a log that is to the base e. All right. Okay. So let's see it. Okay. Common logarithm is a logarithm to base 10. So usually we write as log log y equals to x. So log means log to the base 10. Okay, equals to x. So if I want to find out what is y is actually y equals to 10 to the power of x. So I want to find y, I just anti-log x. We get the answer for y. So this is called common log. Okay, usually most of the question we will solve by common log, but you can solve by natural log. So what is natural log? So natural log is a Neperian log. Is a logarithms to natural base e. So what is e? Okay, so e is a number that is 2.71828182845 and etc. So what is natural number? E. So natural number occurs when a base, okay, over a time it grow, it will produce the maximum growth that is 2.71828182845 etc. So it exists naturally, right? So later on I will show you the what is E, okay, from a YouTube video. So how to write natural log? So we write as ln y equals to x. So now I want to find y. So anti-log of e to logarithm to the base e is y equals to e to the power of x. So you can see the common log is y equals to 10 to the power of x, but for a natural log, it will be y equals to e to the power of x. Okay, so there are some notes that we need to know. There are three notes here. Okay, first note is ln e is 1. ln e is 1. ln means natural log. Okay, ln e is 1. Why I get ln e is 1? Okay, simply just because of a log e to the base e equals to 1, just like log 2, log base 2 of 2 equals to 1. So if this the base and the value here is the same, okay, you get 1, meaning that if e here, and then after you grow, you get e back, that means it's 1, right? The answer is 1. Or log 2 of 2, that means 2 become 2, so 100%. So it's 1, okay? So now ln1 is 0. So ln1 is 0. So the base is e, now become 1. So any changes? None. So none means 0, okay? So log of base e, log to the base e of 1 is 0. So log of any base to 1 is 0. Okay, so because 2 to the power 0 is 1. Okay, 3 to the power 0 also 1. Okay, then lastly is e to the power log, sorry, log ln x equals to x. So this one we can prove by changing the index form into log form. So if we change it, it will become the base here, we change here, all right? So it become ln x equals ln x. So therefore, remember e to the power ln x will become x, or 2 log, still remember, okay, 2x. So you will get the answer x back. Okay, so this is log. Okay, 2 log base 2 of x, you get x. So e to the power of ln x, you get x. Okay, so next slide. So now I'm going to show you this video. So it's around 7 minutes. So we just listen to it. Okay, so.
Okay, have you got your calculator there? Yes? Okay, good. You'll need it in a second. Now, when you hear the word exponential, what's the next word that you expect to come from? Growth. I think is the right exponential growth. And that just means something very fast, right? Well, there's a specific kind of exponential growth that there is. Comes from this. Now, exponential growth doesn't just mean growth that's very, very fast. It means a particular kind of growth. Excel, it grows fast. Right? But XP grows faster. Grows faster. These all grow very fast. But they're all the same kind of growth. None of them, no matter how ridiculous this number gets, none of them are as fast as exponential. Doing something different. People can exponential population. The larger a population gets, the faster it grows, right? And the more rabbits, so the more that there are of them, the more quickly it grows. It's not just oh they'll keep growing faster. It's by their very nature. Well, that's the fast and that's exactly the same thing that's happening with money. The more money you have, the more interest you can make, the more money you have. In other words, what this means is that this is going to get ever faster and it's proportional. Bigger it gets, it's just going to go crazy. Now, think about the just have a dollar. Right? I don't know if you guys know. If you have $5 and you have something to pay, that $5 is going to earn exactly the same amount of cash. Yeah, the five that you're holding, you just can't put it in the file. There's magic in it. Don't you check that. Exactly. So then, you see a consideration from every dollar in my bank account, they're all the same. Okay, now let's suppose it's very, very generous. Now, this sounds very generous, doesn't it? But when you think in terms of the real world, actually, that unusual. It's not efficient. You've got rabbits, they literally can double. Okay? And actually, it doesn't take them a year to grow. Okay? So this is not that unusual. Let's consider 1 year, 100%. What will happen to my dollar? What will it come? We consider one plus the rate, which is just one. Now, as you know, at least if you're dealing with money, they don't wait to the end of the year. And actually, they calculate money. So let's think about it. Suppose instead of waiting for a whole year, they do it semester. Okay? Now, here's what I'm going to have to do. I'm still getting 100% interest per annum, right? So the problem is not going to be how must I adjust this formula? But something's under divided by 2. Okay? Instead of getting 100% at the end, I get 50% at the end of the month. That's this 1.5 is going to be 2.25. Okay. So this is better. This is good. Okay. Well, why just put it once every 2? Why don't we do it every month? 1 plus 12. 12. Okay. That's it. $2.60. Okay, now this is interesting. Look, when I double, I got an extra 25 cents. So that here, more quickly, but I'm still gaining 4. That's something new. Don't do it every day. Don't play every day. So, what equation should I write? 1 plus 1, 1, 3, 5. And every day, you're going to go. You calculate it. Tiny, tiny, tiny. 2, 3. Now, give me some more decimal places. Okay, all right. Now, what's going on? Right? I would say from monthly to daily, you can store rate dramatically. But all you gain is like particularly consistent, right? Well, just for the sake of it, maybe you think you get it. Every day, we have 30 plus computers now. Just do it every minute. Okay? Number 5. So let's go. 1 plus 1 on every day is 65. How many hours? 24. How many minutes? Whatever that is. Someone's calculating. Guess what? Spoilers. 2.71828, blah, 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 blah. What happened? Now, here's the thing, right? I didn't even get a whole set out of it. I suppose you can know. What happened? Well, you know what? Like all of these images are you get all of this days, months, hours, who your people do. They just say, well, what happens if you just say, now, it must be put this because of course you can't actually. You can take some other. You can take like whatever large number you want. Put it a trillion, and I'll tell you right now, you're going to get it off. This number. It's like I didn't say, oh, it better be a certain. It comes from a structure that is namely or how things became when they became. Half-lives, temperatures come down, but what if something is the faster it uses? This is the number of proportionality. Proportional growth or proportional growth. And that's why it's so important. That's why I think it's a number that
Okay.
okay, have you got your calculator there?
All right. So this what is E, right? Okay. Now we can go to the next slide. Okay, the solve problem. So express the following as a single logarithm or ln x equals to ax plus b. So let's solve it. All right. So number 1, 3 log to the base a 2 minus 4 plus log to the base a of a to the power 3. So what we do is the 3 in front you need to make it become the power, and then 4 you need to add log base a of a. All right, so what you do like this. Okay, so log, sorry about that, so log the base a to the power 3 minus 4 log a plus 3 log to the base a of a. So here you can see negative 4 plus 3. The log is same. So you'll get negative 4 plus 3 as become negative log to the base a of a. Right? So we want to express in the single logarithm. So we combine everything. Plus become divide. Right? Plus become multiply. And then minus become divide. Right? So you get log. Finally, you get log to the base a of a over a. Right? So add minus log to base a of a, it become divide. Okay? So this, right? Negative become divide. Okay, so if I show you log, okay, A minus log B, so it become, so remember this log A over B. So we use this method, right? So number 2, 3 minus 2 log 5. Log here, log means log to the base 10, right? So we change 3 become log 3 log 10 minus 2 log 5. So log 10 means log to the base 10 of 10. So you get 1. So 1 times 3, you get 3 back. So there's nothing wrong here. Then we combine these two. Before we combine, the 3 you move become the power. Okay, so you get log 10 to the power 3 minus log 5 to the power 2. So 2 also bring as a power. All right. So now we can combine these two. If minus, then we make it become divide. That is log 1000 divided by 25. If 1000 divided by 25, you get log 40. So the question didn't ask you to solve it, but just to simplify it. Okay, express in a single logarithms. Okay, number 3. Okay, so number 3 involve e, right? So x times e to the power x power 2. So this one just like the index. Okay, so x to the power 2, and then x times 2 become 2x. Okay, so this part, okay, so you get x to the power 2 e 2x, then equals to 30 over e to the power x, because here is negative, right? E to the power negative x, it will become over e x, e to the power x. So then the e to the power x, you times, right, this part, okay, e to the power x. All right, so we don't times, but we take ln for each, for both sides. So you get ln x squared e to the power 2x equals to ln 30 minus x ln e. So how to get this? All right. So this here is from here, we ln, you bring ln for both sides. So 30 divided by e to the power x become 30. So ln 30 minus ln e to the power x. Alright, so then we can simplify, become make it become ln 30 minus x ln e. Okay, so ln e will become 1. Alright, okay, and then this one multiply x squared times e to the power 2 x. We can separate into 2. That is ln x squared plus 2x ln e equals to ln 30 minus x ln e. Alright. Right, then you the 2, you bring the front, become 2 ln x plus 2x. Why 2x? This one become 1. Okay, ln e is 1. This one also 1. So therefore you get 2 ln x plus 2x equals ln 30 minus x. So you will bring the ln to the left hand side. Okay, so you get 2 ln x. All right. Okay. Also no need. Okay, so 2 ln x equals to ln 30 minus 3x. How to get minus 3x? So 2x we move to the right hand side. So minus x minus 2x, you get minus 3x, because we want to get in the, we want to write in this form. So ln x equals to ax plus b. So now we almost done. So we just divide 2, okay, both sides. Okay, so you get ln x equals to half ln 30 minus 3 over 2 x. So So this part will be your A, and then this part will be your B. So after you find with your calculator, half times ln 30 is 1.7 and negative 3 over 2 is negative 1.5x. So this negative 1.5 is your A and 1.7 is your B. So this is how you convert, right? So this form into ln x equals to ax plus b. All right. So next, solve for x of the following equation. All right. Right. So we cannot, for A, you can see here A is 6 to the power of x plus 2 equals 21. All right. So we cannot change 21 into base 6 and the power is in round number, right? So what we do, we have to take both sides log. Okay, so log 6 to the power x plus 2 equals to log 21. So log here means log to the base 10. Log means log to the base 10. Okay, so in your calculator later on you can see log there. All right, so then we move the x plus 2 to the front. So you get x plus 2 log 6 equals to log 21. So we want to solve x, remember? So we have to expand this part. So become x plus 2, or no need to expand, okay? So we just divide log 21 divided by log 6. So log 21 over log 6, okay? So if you use calculator, how to find this part? We just use this button, okay, log, and then you press 21, all right, divide by log again, and then 6, then you get equal, or you can use this button, okay, numerator above, you use log 21, and then denominator is log 6, then equal. You should get the same value as what I mentioned just now. You find log 21 first, and then you divide by log 6. So manually you get this, okay, 1.32222 over 0.7782. But if you use this button, this function, all right, so you will get the answer straight away. That is 1.6992. So x will be negative 0.3008. All right, so that is 1.6992 minus 2. So you get negative 0.3008. Okay, so this is for A. And for B, okay, B is e to the power 3x equals to 9. So we change this into log form, so ln form. So 3x equals to ln 9. And then x will become ln 9 over 3. So using calculator, we use this button. Okay, so we just press this fraction. Then numerator is ln. Press ln 9. And then over, no need, right? Because already in the fraction. So in the new denominator is 3. So you press 3, then equal. So you get the answer x. All right, x equals to 0.7324. Okay. So this is how you solve B. Then we go to C. Okay. Okay, let me clear off all the pen there. All right, so 3x times 4 to the power x, 3 to the power x times 4 to the power x equal to 7 times 5 to the power x. So we want to solve x, right? So meaning that we need to shift all the x into the left hand side or to the right hand side. Okay, so what we do, so since this is in index form, okay, if the power is the same, then we can multiply the base, right? 3 times 4. So it becomes 3 times 4 to the power x, then equals to 7 times 5 to the power x. Then we bring 7 to the power x to the left hand side by dividing both sides. So you get this, right? 12 from where? 12? 12 from 3 times 4. So 12 to the power of x over 5 to the power of x equals to 7. Since the power is the same, then we can divide the base. Okay? Now we simplify like this. Okay? Then we take both sides log. Okay? So log 2.4. How to get 2.4? 12 over 5 is 2.4 to the power of x equals to log 7. So you take log for both sides. If one of the side, both sides, we cannot find the common base. All right? So we have to use the log to solve. Okay, now bring the x to the front, this x to the front. So you get x log 2.4 equals to log 7. Then how to get x? Find x, so we divide both sides with 2.4, okay, and then 2.4, log 2.4. So you get x equal to log 7 over log 2.4. So by using your calculator again, okay, using this pattern, okay, so log 7, and then for numerator, the denominator is using log 2.4 equal. So you get your answer 2.223. Right? Alright, so this is how you solve for x for the following equation involving index number, but you cannot solve by equaling the both sides with the same base. But so you need to use log to solve. Okay. Now solve for x for the following equation. Continue. All right. So here is e to the power 3x plus 2 to the power 2 times e to the power x equals to 3 times e to the power 2x. So what should we do? So we want to take out x, right? So we factorize out. Okay, factorize out the ex because all the terms here can be divided by ex. So we'll get ex as mean divide, right? So 3e to the power 3x divided by ex. So you get e to the power 2x, and then plus 2 equals 3e to the power of x. Okay? So then we bring the 3 times e to the power x to the left hand side. So you get the new equation that is e to the power x times e to x minus 3e to the power x plus 2 equals 0. So since e to the power x equals to 0 are not defined, so meaning that e to the power 2x minus 3 to the power 3 times e to the power x plus 2 equals to 0. So this part we need to substitute e to the power x with y. So you get y equals to e to the power x. So e to the power 2x actually is ex to the power 2. So we can write as y to the power 2 minus 3y because e to the power x is y, and then plus 2 equals 0. Then we factorize this part. So you get y minus 1 times y minus 2 equals 0 by using your calculator. Right? So then you get y equal to 1 and y equals to 2. But we want to find the value for x. So we need to change y back to e to the power x. So like this. So e to the power x equals to 1 or e to the power x equals to 2. So I want to find x, then I need to change into ln form. So you get x equal to ln1 or x equal to ln2. So you use your calculator. X will become 0. ln1 is 0. And then ln2, if you use a calculator, you get 0.6931. So the x values is 0 or 0.6931. Okay. E, right? So E, you get ln2 times ln4x equals to 3. So I want to find x here. So I need to move ln2 to the right hand side. So I have to divide. Right? So divide both sides with ln2. So you eventually you get ln4x equal to 3 over ln2. So this part we can use calculator. Okay, but before that we want to find what is x first. So this part ln we need to change into this log form, we change into index form. Therefore, you get 4x equals to e to the power of 3 over ln 2. Oh, sorry, ln 2, all right? So what is x? Not yet finished, right? So x equals to e to the power of 3 over ln 2 over 4. So you use your calculator, okay? So e is the, in your calculator is a small red e, okay? So you should get x equal to 18.9497, okay? So continue. So this part for for E, all right? So the how to press E here? Okay, you just press Shift, Shift, right? Shift, and then this button here down there near to the ANS there. There's a button times 10 to the power of x. That you get E. Okay. So that's how you use your calculator. Now is F, right? So F, I want to find X, right? But on the left hand side, so there's left hand side is log, log to the base 10, and the right hand side is ln. There's log to the base E. So what we do? Okay. What should we do? Okay, so we need to change the log into index form. There's x minus 1 equals to 10 to the power log ln e square minus 1. So this is power, remember? This part is power. So maybe some of you are confused. This is small letter. Small is a small letter that meaning that is a power. Okay. So and then if you use a calculator, 10 to the power of ln, and then bracket e square minus 1 bracket, you get 71.55. Right, so x minus 1 equals 71.55. Therefore, x equals to 72.55. All right. So how to press this? If you are not sure, please ask. Okay. Okay. So this is the challenging exercise. So this exercise is not in your textbook. So if you want to do it, please pause it. I'll show you the answer by this week. Okay, by Friday. All right. So please go through everything, the explanation from the first slide until the example 20. All right. Then try to do this exercise. Okay, so I give you a few minutes, then we can continue the next video. All right.